Hello everybody. So I am so pumped because today is our truly our first day of actually doing a little bit of math. Day one. Now I have done something bold. If you do try to follow me in the textbook, I am all over the place for the first chapter because I did not like the way the chapter was written. It did not build naturally, so I have reconstructed it. So in saying that, don't follow me in the book. Okay. Now, something else about today's lesson. It should seem pretty easy to you. We are building. We're going to start very simple and build, because that's the way I prefer to teach math. I prefer to build our math upon things that we know. So today's lesson, short, simple, sweet, easy. Actually, all of chapter 1, for the most part, should be review for you. Review because it's not really the deeper stuff of algebra. So don't panic or think the whole class is just going to be super easy. Just know that it will build, but so will your knowledge of math. If you are struggling with any of this material, that's okay as well, because I know sometimes if you haven't touched math in a while, it's hard to remember it all. Hopefully, I can teach you not to remember math, but to understand math. That's kind of my goal for teaching math, is to have a close relationship where you're not anxious, because anxiety makes math hard, and where it kind of makes sense logically. Now, before I begin, I do want to say that I have loved y'all's drawings from y'all scanning in. Some people are a little bit more artistic than others, but I love every smiley face and blob that I can't tell what it is, and some of the more beautiful drawings. They're wonderful, and I love y'all's feedback. Keep trying to scan those things in. We're doing that so that all the rest of the course will be easy to scan in. Okay, so for this lesson there will be a worksheet. So make sure you work on the worksheet. It will be posted right below this video, and there will be a Mymathlab homework. So make sure that you are in Mymathlab. If you are not in and you're watching this video, if you can't do either of these, if you can't scan in your answers and you can't do a Mymathlab, you need to get help somewhere from me or Google or a friend or a classmate. Alright? So let's get started with the material. Today's lesson. So we're going to actually try to build the entire class off of some very simple knowledge, off of the very beginnings of like numbers. So we're going to go very, very basic and simple. Let's talk about a number line. I know that sounds stupid, right? But we can use the number line to build a lot of ideas and concepts to feel cozier with this. So the number line is just a line of numbers, and so I'm going to count, by ones in both directions. Over here on this side, we going into the negative numbers. Okay, so as far as I can go, that's why I have the arrow on the end. So that means this thing goes forever, but I don't have a screen that goes forever, so I can't draw the whole entire thing. Okay, so I do want to point out some things about this. I want to point out that the negatives are going this way, while the positives are going in this direction. I want to point out that as you go to the left, as we're going this way, these numbers are smaller. So the further to the left something is, the smaller it is. Don't ask me why I drew a squiggle. I just draw stuff sometimes. So over here are smaller numbers. The further to the right you go, the larger the number. So let me tell you why I am explaining this. Some people struggle with telling me which number is bigger, -3 or -2. Which one is bigger? Well, the further to the right, the bigger the number. So -2 is bigger than -3. A lot of people said, well, yeah, duh, but some people said, huh? When I said that statement. But it's easy to think about. If you ever feel lost, think about money. If you have -$2, that means you owe me $2. If you have -$3, that means you owe me $3. You're in debt. Which one means you have more money? Well, if you're less in debt, you have more money, right? So -2 is a larger number than -3. So I do put the green part just to discuss that idea. Okay, so that seems to cover things, right? But I do have a question for you. What about fractions? Or decimals? Because all I have are the pretty numbers, right? 0, 1, 2. What about 1.235? Could I throw that on the number line somewhere? The answer is yeah. So I can easily plot whole numbers. So if I want to plot 2, boom, that's easy. I can put a dot at 2. But what if I wanted to plot, let's do something like this. What if I wanted to plot 3 halves? Where does that go on a number line? Here's the easy way of thinking about it. You're allowed a calculator for this class. So actually, I don't have that calculator installed, so I'm going to just lazily pull up the Windows calculator. Not the best calculator, but it works. Let's see. That's good enough. And I can just type any fraction. So this is 3 over 2. 3 halves. 3 over 2. I can type any fraction as a division. 3 divided by 2. So 3 over 2 and 3 divided by 2 represent the same number. And if I hit equals, it tells me that is 1.5. So this is the same thing as 1.5. What I find as, at least as Americans, the way we think in numbers is a lot of people think in decimals, not in fractions. I encourage you to get more cozy with fractions. Most American kids have this fear of fractions, most American students, and that carries all the way through to college. But actually, you'll see throughout this chapter that fractions are maybe a little bit nicer and should kind of be more your friend. So could I plot 1.5? Well, 1.5, we know it's bigger than 1, and it's not 2, and a half means exactly in the middle. So I could plot that number, 1.5, I could plop it right there. Now, we're not going to ask you to be perfectly exact on any of these, so if I gave you something like 3.9, that's past 3, right? But not all the way to 4. 0.9 would be closer to 4, so that would be like sitting right along in there. So you can't be exact with this, but we try to be close. All right, so we could plot numbers. That's not too hard. So for example, you might get questions like this. You might get a beautiful number line. Y'all love my beautiful number line. I know. Don't hate. I'm just going to put a 0 and some marks. I'll put the numbers in once I see it, how many numbers we need. All right, and I'm going to say, okay, well, plot these. And what I'm going to do is list them in a special way. It's called roster form, when you just list out a roster of numbers with commas in between them. And some people are like, what's that squiggly thing that you drew? That's just a special notation to say, hey, I'm fixing to list some numbers, okay? And I'm using this because we will talk about this later. It is important for whenever I list some numbers. This is called roster form, and it's a list of numbers, and this is a brace. These braces mean here's a list of numbers. In mathematics, this is used to notate something called a set. A set of numbers just means a group or a list of numbers. Okay? Don't tell anybody else I use those words, because if you get high up in math, those words have special different meanings. So I can plot all these things, right? All right, let's add some labels. -1, -2, -3, -4, -5, -6. 1, 2, 3, 4, 5, 6. All right, let's see. -2. Can I plot -2 on here? Yeah, that one should be easy. -2. Could I plot 0 on here? Well, that one should be easy as well. Boom. 5 halves. Let's come back to that one. 6. No problem, right? So 5 halves. I know where 5 halves goes because I've done a lot of fractions. But if you have not done a lot of fractions, what is 5 divided by 2? Well, we can just grab our calculator and say, okay, 5 divided by 2. Boom, and it will be 2.5, or 2.5. So that is beyond the 2 but not to the 3, somewhere in the middle, and actually a half is perfectly in the middle. So I can plot these things without too much stress, right? Awesome, not too bad. The next thing we want to be able to do is compare numbers. Can you compare numbers? So you know we have these special symbols to compare things. For instance, if things are the same, I can put an equal sign, right? But if something is less than or greater than, I use these symbols. Okay. And if you tend to get these confused, I understand. I am dyslexic. I'm sure that instills a lot of confidence in you that you have a dyslexic math teacher. No worries, I'm fine with it. It mainly messes with my reading. But I can just concentrate hard enough now in life. So the less than symbol, the easiest way to remember which one's less than and which one's greater than, if you tend to forget, is if you notice, okay, don't write this part down, but if you notice, it kind of looks like an arrow if I were just to add a stem on it. In which direction is this arrow pointing? To the left. What's the first letter in the word left? L. What's the first word in the word letter in the word less than? L. So that's one way to remember it. And obviously, the one pointing the other way is not less than, so it must be greater than. Okay. So I'm going to just give you some numbers. -8 compared to -12. Is -8 less than -12, greater than -12, or equal to -12? Or if you're lost and you're like, oh, I don't like thinking about negatives, could you plot them on a number line? Yes. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's -12 right there. Where's -8 at? 1, 2, 3, 4, 5, 6, 7, 8. There's -8. What did I tell you? The further you go this way, the smaller, right? So -12 is smaller than -8, and -8 is larger than -12. Does everybody agree? -8 is larger than -12. So if I want to make this like a math sentence and it reads from left to right, we say -8 is greater than -12. Okay. Do you have to use the number line? No. If you know it, if you just look at that and in your heart you know -8 is larger than -12, good. Put your greater than. If you struggle or you're confused or you doubt yourself, draw a number line. Further to the left, these things are smaller. Further to the right, these things are larger. And then read it left to right. Okay, let's do another one. How about 0 compared to -7? Oh, we can just do this in another color. We'll do it in green so I don't have to draw the number line again. Here's 0, and here is -7. -7 is smaller, 0 is larger. So 0 is larger than, greater than -7. So this is pretty easy, you're thinking. Or you're either thinking, oh man, I'm going to have to draw these number lines the rest of my life. You won't. You'll start to get a real coziness with numbers at some point the more you do this. So be sure to practice. All right, let's look at this. -6 compared to -2. I'll do these in blue. Here is -6. Here is -2. So -6 is over here. It is smaller. -2 is over here. It is larger. So which one's first? -6 is smaller than. That means less than -2. Okay. So you can use the number lines. If you have any doubts, please draw a number line. It makes it simple. Okay? So, I know you're thinking, man, that's like, what? I don't know. Somewhere back in elementary school we did less than or greater thans. But most people don't even like remember it or even bother remembering what the symbols are. So, just a good little refresher. I told you nothing hardcore today. I got one more or two more topics. It's kind of 1.5 more topics. Okay, I want to talk about two different words. I want to talk about the words opposite and reciprocal. Okay, these are two mathematical phrases, mathematical words, that have some meaning that we can use throughout the whole course. Because this is algebra, we're going to get into using opposites and reciprocals a whole lot. So you need to know what exactly is an opposite and what exactly is a reciprocal. Well, what is an opposite? We would have a discussion if we were in class, but you're not here with me, so this is awkward, just me talking to myself, sitting in my office. What is an opposite? And while I'm here, what is, well, reciprocal? Well, an opposite is when we have the same number value but different sign. So what is an opposite? It's same. And when I say sign, I mean negative or positive. One of those two. So for instance, what's the opposite of 5? The opposite would be negative 5. What's the opposite of negative 7? The opposite would be positive 7. So you just change the sign. Okay, what about a reciprocal? Okay, so the root word here, the Latin root word, or not Latin, but the root word here is to reciprocate, and that basically means to flip back and forth. So reciprocal is when there's some sort of a flipping involved. Okay, that's not a math term very well. It's a horribly loose just English term, but it's okay. Hopefully the math police won't get me. So the reciprocal of a number is when you, okay, here's quotes, flip the fraction. So this is actually really easy when you have a fraction. So 2 over 3. What's the reciprocal of that? Reciprocal of that is 3 over 2. Piece of cake, right? It gets a little weirder when it's a whole number, but let's do another one. How about negative 5 over 7? What's the reciprocal of that? Can you write the reciprocal? Well, let's see, it's negative, so I'm not changing the sign because I did not tell you to do the opposite, right? But to reciprocate it or to flip it, it would be 7 over 5, okay? So a reciprocal is just flipping the fraction. An opposite is just changing the sign. So I could ask you to give me, hey, I could ask for both at the same time. So I could say positive 8 over 3. What is the opposite reciprocal? So can you tell me the opposite reciprocal? Well, let's just do the reciprocal first. 8 over 3 would be what? 3 over 8. Opposite, what sign is this one? Positive. So what sign is this one? Negative. Okay. So what if I want to find the reciprocal of a whole number? That's an interesting kind of thought. What if I want the reciprocal of something like 7? It doesn't appear to have a fraction part to flip. But this is where I want you to remember. I can turn any whole number into a fraction by putting it over 1. Why does this work? This works because I told you that's just like dividing by 1. Does this change the value of this number 7? No. If I divide anything by 1, it stays the same. So 7 is the same thing as 7 over 1. I can do this with any whole number. 259 is the same thing as 259 over 1. I can always just add a 1 to the bottom. I mean, if we want to get more algebraically advanced, 3x, I could literally write that as 3x over 1 if I need it to be a fraction. Okay? So if I can write it as a fraction, now it should be easy to find the reciprocal. What would the reciprocal be? 1 over 7. Okay. I hope that's making sense. Now, there is one number that we don't ever try to find the reciprocal of. It's the reciprocal of 0. And I'll kind of explain a little bit why. So if you said, oh, well, just turn it into a fraction, okay, that's fine. There's nothing wrong with that. And then if I want to get the reciprocal of it, I flip it. Okay? Well, let me go ahead and explain to you. In math, having a 0 on the bottom is a bad thing. That means that it is undefined. And I can explain this to you because the bottom number of a fraction is what you are dividing it by, right? That's how many pieces we are dividing this top into. So I can divide something into one piece. So if I give you a candy bar, I say, hey, divide this into one piece. Well, you just have that one candy bar, right? There's no cutting required. You can divide it. You can divide it into 2 pieces. You can divide it into 3 pieces. You can divide it into 10, 100, a million. But can you have a candy bar and cut it into 0 pieces? Can you have something and have no pieces of it at the same time? No, you cannot. You cannot have a candy bar and not have a candy bar at the same time. So dividing by 0 is not allowed. So if I ever ask you to find the reciprocal of 0, you tell me it is undefined. Okay? Alright, awesome. So I'm going to leave you right there as far as the lesson goes. So what you need to do is do the worksheet. Okay, so in Blackboard, you will find our worksheet. Oops, I can't spell. Make sure you do that. Okay, and make sure you scan it. Oh man, I really can't spell. Scan and post as a PDF. I'm struggling as PDF in Blackboard, okay? And then you will have a Mymathlab homework to do as well. Make sure you do that. It will also be in Blackboard, the link for it. Alright. If you have any questions, you can email me. I hope you have an awesome day.